As we move on to section 8 with the sum and product of quadratic roots, what we're taking from this is that we've learned that the two roots from a quadratic using the quadratic formula, the only difference is one has a minus in here and one has a plus right here. So as we play around with this, and maybe I need to remind you, just in case anybody's forgotten, that we have y equals ax squared plus bx plus c from those directions. So if I ask you to add those two values together, what I'm talking about is the negative b of the minus of the square root of b squared minus 4ac all over 2a plus the other problem, negative b plus the square root of b squared minus 4ac all over 2a. Now, I would assume you know this, but if you don't, I'll go ahead and write it for you, that you can add these together because we have the same denominator. And addition's commutative, so what I can do is I can just add them, negative b plus negative b, so that would be negative 2b. And what happens if you have a negative square root with a positive square root? They add to get you 0, or you could say that they cancel each other out. And at this point, all we're left with, I was using that color, is negative 2b divided by 2a. Well, the 2's cancel each other out. That 2 divided by 2 is 1. So we're actually just left with negative b over a, which is kind of interesting. So as long as we know the a value and the b value, we know that the sum of their two roots need to add to equal a and b. And then we're also asking you to multiply those two things together. So I didn't give myself enough room. But it's really the same thing as this, except we're multiplying in between. So where you have a plus right here is going to be a minus, or a multiplication. I was thinking about what I was writing right there. Over 2a, and then times. And what's different about this problem is a couple things. Is in the previous problem, we had the same denominator, so we could add them together. But this time, when you have the same denominator, you can multiply anything. You just have to do 2 times 2 is 4, and then you'd have a squared. And then the other bit that's different is we're multiplying, but what you actually have to do is FOIL the numerator, F-O-I-L. But I don't need that much space, because if you do negative b times negative b, it's positive b squared. Now the outside gives me a negative answer, negative b times something, and then the inside gives me a positive. A negative times negative is positive, but they cancel each other out. So the outside and inside terms cancel each other out. And then the last term, a negative times a positive, is negative, but this time the square roots cancel, because the square root squared undo each other. And so what you should notice as I distribute that negative into the problem is the b squareds cancel, and as I distribute, that becomes a positive 4ac. And I'm going to rewrite the denominator as 4 times a, because one of the 4's cancel, one of the a's cancel, and what we're left with is just c over a. And we've actually been doing this. That the way that we've been finding the factors is by doing the AC method, because it helps us find this. So based off of a quadratic, let's just write down these rules. The sum of the two roots is negative b over a, so this number divided by this number, and then the product of the two roots is this number divided by that number, c divided by a. So without even doing the problem, we can quickly find the sum and the products of these two roots just by following that formula. So the sum of the two roots has to be negative of 8 divided by 2, which gives me negative 4. And then the product of those two roots needs to be the c value, which is negative 3, divided by the a value of 2. So if you did the quadratic formula, you can find the two roots and then answer this question from here. So the same thing goes with the next one, is that the sum of these two problems, of the two roots, if we were actually to find them, would be negative b over the a value. And then the product of my two roots would be equal to the c value, which is just negative 20, divided by 5, which would give me negative 4. So moving on to the next one, I guess what you could do is you could try to find all the roots of these problems, or we could try to investigate why the sum of the roots have to be 5 and then the product of the roots has to be negative 3. So if you go back to the formula that the sum of the roots is negative b over a and the product of the roots has to be c over a, let me write that down. B over a, and then the product is c over a. And what we can do is we can just see which ones work. So if the sum needs to be 5, then negative b divided by a needs to equal a positive 5. So as you go through the options, like on this one, it would be negative of 5 divided by 1. Remember, there's an implied 1 right here. Well, negative 5 divided by 1 is negative 5. So that doesn't work. Option 2 would work, because remember, it's the negative of the b value, so positive b over a. Again, the a value is 1. I'm not sure why I wrote it that way. There we go. And you can see that the other two don't work either, because that doesn't work. 3 and 4 don't work. But you can confirm that the product does work as well, because if you do negative 3 over 1, the c value divided by 1, that option 2 works. And so why would I concern myself with that? Well, if we have a problem like this, we could quickly come up with what the correct parabola would be, which one of the quadratic equations has these roots, without actually doing the quadratic formula. So the thought process would be is that the sum of the roots would be adding them together. So 5 plus root 7 plus 5 minus root 7. So let me write down that that's the sum, because I added right there. Well, if you reduce that, you get 10. And I can remind you that the sum formula is negative b over a. So as you look at my options, well, option 2 and option 3, negative or positive 5 divided by 1 does not give me 10. And then negative 7 divided by 1 does not give me 10. And what the correct answer would have to be option 1. Because it's true that the negative of negative 10 would be positive 10 divided by 1. We could also confirm, although it's a lot more math to do, that the product, so if I did the product of these, it would be 5 plus root 7 times 5 minus root 7. And if you work that out, it would be 25 plus 5 root 7 minus 5 root 7. And then a positive times a negative is negative. Root 7 times root 7 is 7. And 25 minus 7 gives me 18, which has to be the c value in this problem. So that's a way that you can confirm that option 1 was correct. So just to give you a different way of approaching a problem is having two different quadratic equations. So I'm going to try and keep this as simple as possible. We have ax squared plus bx plus c. And remember, the sum have to, it's the formula negative b over a, has to equal 9. Well, I could keep this as simple as possible, and I could just let a equal 1. Sometimes I actually write that out. Let a equal 1. So then negative b divided by 1 has to equal 9. So b must equal negative 9. So while I have that as part of an answer, so a is 1, x squared, minus 9x, then my product being c over a has to equal 6. But again, a equals 1, so please let me know if you are confused, if this is acceptable. Now what I would do is I think about how the roots are the x-intercepts. And you may remember from a previous lesson that the x-intercepts have to be the same ratio. So what I could do is I could just double every one of my answers, and this will also give me the same roots. And you could confirm, because negative b, so positive 18 divided by 2, still gives me 9, and the c value of 12 divided by 2 still gives me 6. So what's different about the next one is that they want you to have a leading coefficient, so they want you to have an a value of 3. So in order to get this problem to set up this way, my final answer is going to have y equals 3x squared, and then something x plus something. I don't really know. But what I need to do next is find out what the sum of these two roots are. So 4 plus root 3 plus 4 minus root 3. And you can see those roots cancel. You just left with 8. So the sum of the roots is 8. And remember, our formula for the sum is negative b over the a value equals 8. But remember, we just said that a equals 3. So negative b over 3 has to equal 8. So as I multiply the 3 over, negative b must be 24. So it makes sense to me that the b value needs to be negative 24. And then I also need to figure out what this product is. And it's a little bit more work, but it's not that much. And we've been doing work with conjugates, so hopefully you can do this pretty quickly. That as you FOIL it, the 4 times 4 is 16. The outside and inside terms cancel, and then root 3 times negative root 3 is just negative 3. So we're looking at a product of 13, which is the formula c over a is equal to 13. And remember, they said that a needs to be 3. So if I multiply the 3 over, my c value needs to be 39. So if you have any questions or if anything seemed like magic there, I would encourage you to write down your questions and then come to class with them. So this next one's set up a lot different. This time it's setting it up with a y-intercept of negative 2. That means your c value has to be negative 2. So what I would actually start with is the formula that uses the c value, and that was the product of the roots. So 3 plus root 10 times 3 minus root 10. And again, we've been doing work with foiling and conjugates, so you get 9. The outside and inside terms will cancel. And then root 10 times root 10 is just 10. So the product of the roots needs to be negative 1. And remember, our formula was c over a needs to equal the product of negative 1. And now that we know that the c value is negative 2, I can cross multiply. Multiply the a over, so negative 2 equals negative a. So a must equal positive 2. So 2x squared, I don't know what the x term is, but I do know that my constant is 2. And now I would go back and find the product of the sum. And that would be 3 plus root 10. I said 10, but I wrote 2 for some reason. And then plus 3 minus root 10. Radicals cancel, we're left with 6. And remember, our formula is negative b over a needs to equal the sum. And we just figured out that a equals negative 2. Well, negative over negative is positive. And I'm thinking out loud, how do I get 2 to the other side? Well, I can multiply it, and I get my value to be 12. And then this should be your perfect answer. So again, if that seemed like magic, or if you're confused on something there, please write down your question and come to class with it. Otherwise, you're ready for the homework.